Hi there guys, in this video we're going to have a look at what we call negative indices. Now we know these exist by, if we do a simple sum like this, we get 7 to the minus 2. Now as mathematicians we're not very happy about this situation, we need to rewrite it in a different form. And now to explain this I'm going to use this example first. I'm just going to rub that out. So there we go. Okay, so let's write some really simple indices that we know. Okay, so 10 cubed, 10 squared, 10 to the power 1. And what we're going to do is we're going to use these really simple numbers to just look for some patterns. That's what good mathematicians are. I'll just leave it like that. Okay, so 10 times 10 times 10, that's 1,000. 10 squared, 100. 10, anything to the power 0, well that's 1. Okay, so let's look what happens. What happens when we're reducing this by 1? Okay, we're dividing by 10. So if we continue that pattern on, we can have divided by 10, divided by 10 again, which is divided by 100, divided by 10 again, that's divided by 1,000. Okay, so 100 over here we wrote as 10 squared, so we could write that as 10 squared. 1,000 we could write as 10 to the power 3. And 10 we could write as 10 to the power 1. So as a mathematician you should be able to say, oh, what happens when we are using these negative indices? Well, the indice is positive, but now it's a denominator and we've got this 1. Okay, so where does this 1 come from? That's the question we need to ask ourselves. But first of all, let's just move that. Let's just take this and let's move it over here for now. So using this pattern, it's really simple. If I said what is, get the pen, 3 to the minus 2, using this sort of thing, we can say, well, that's going to be 1 over 3 squared. The power becomes positive. And 3 squared, that's 9. If I said what is 4 to the minus 3, that's 1 over 4 cubed. 4 cubed is 64. Now it gets a little bit harder when there's like an A. So we can't actually go further than this, but it's A squared. But it gets even harder still when I put something like this. So to answer this question, we have to fully understand, why is there a 1 appearing here? And why isn't there, or is there a 1 here? So I'm just going to get rid of all this and we're going to look in a bit more detail about what's happening and where this 1 is coming from. Okay, so let's use this one. So we know we can rewrite it like this: 3 to the minus 2. And there's a 1 appearing. So is there a 1? And actually there is, because we could write 3 as 3 over 1. And now if I put it in a bracket, you can see it automatically looks like this. And we know the answer is 1 over 3 squared. So I know at some point that these flip over and you can see this is squared. Well, if I put a squared there, you'll see that it's actually still 1. And that's exactly what's happening. With a negative indice, what we do is we reciprocate. Reciprocate. Okay, you reciprocate quite a lot in maths, especially when you know timesing and dividing fractions. Not timesing, dividing. And a reciprocate of a number is it's what you times by to make it equal 1. Okay, so the reciprocate of 3 is a third, because when we times them, it equals 1. Okay, just get rid of that. Oh, it's a bigger rubber. There we go. So when you see a negative index, you've got to think, oh, that's when I reciprocate. And actually, this means 1/3 squared. So 1/3 times 1/3. 1 times 1 is 1. And 3 times 3 is 9. So why do we always put the squared there? It's because 1 squared is always 1. Okay? So if we get a more complicated number like this, we reciprocate. And that actually removes this negative power. So 6 squared is 36, and 5 squared is 25. But unless you realize actually what is happening, these questions are really complicated. Now, I'm going to just get rid of all of this again. There we go. But what happens when we make it even a bit more complicated? So if we take 4, let's do 4a to the minus 3. So we can write this into what we call a fractional form. But to do this, you've got to understand this means 4 times 1. Ooh, silly man. 4 times a to the minus 3. And we can rewrite this. We can say, okay, using what I've just seen before, if you like, you can now think of it always like this. This is a good habit actually to get into. So that's going to be 1 over a cubed. Remember, we reciprocate and it's cubed. We don't put 1 cubed because that's 1. Okay? And if we tidy this up, if you're confused about what happens here, remember, times in fractions, we can make that a fraction. Times the tops, times the bottoms. So it's not always a 1 over again. So if you don't understand this process, if you don't understand this bit is very confusing because you might have been taught it's always 1 over. It's not. If you've got more than one of them, then it's definitely not going to be 1 over. So why don't you pause the video and have a go at these two here. Okay, so if you're ready, that's going to be 5 lots of m to the minus 3, which is 5 lots of 1 over m cubed, which is 5 over m cubed. Now, there's plenty of students who go, oh, got it, I see the pattern, and they just go from here to here. You're understanding something. It's about learning and making sure in a pressure situation you can understand how to get from there to there. So if this is the first time you're watching, make sure you're not skipping these stages. These stages are vital for you to build a long-term memory of what's actually happening. Okay? Let's make it a bit more challenging. Why not? What about that? So again, if you learn simple rules, I'll give you this one, you'll get confused. So if we approach it from this angle, this should be fine. So that is actually 3/5 multiplied by m to the minus 2. You imagine there'd be a 1 there? 3m to the minus 2 and 5. So that's going to be 3/5 times the reciprocate. I've put the divide by 1 there, so I'm going to make it look like this now. So 1 over m squared times tops, 3 times the bottoms, 5m squared. So that's it. That's really important to understand negative indices, all the different types, and why it happens.